Hi guys, we've got an incremental change question today where it's saying use the method of small changes to find the approximate change in the radius of a spherical balloon corresponding to a change in its volume from 500 centimeters cubed to 499 centimeters cubed. So basically what's happening is the balloon's getting smaller, so we'd expect the change in radius to be a negative number. So what we need to do here is let's just define our method of small changes, or the incremental change formula. So what it basically says is the incremental change, or delta y divided by delta x, can be approximated by the derivative of y with respect to x, and this is for small changes in x. Okay, so what we've got here is we've got the independent variable. What is changing in our situation here is the volume. So we have a method of finding the volume in terms of the radius. What we need to do to start with is we need to rearrange this formula so we can have the radius in terms of the volume. So what we're going to do is we're going to do a bit of simple algebra. We're going to times both sides by 3, divide both sides by 4 pi, and then cube root each side. So we're going to end up with r is equal to the cube root of 3v divided by 4 pi and that's it. So what we're going to do is, from this formula here, we can manipulate it to give us what our delta y is going to be, or in this case delta r. So we can say, I'll change the color, that the delta r is going to be equal to dr dv evaluated when volume is equal to 500 multiplied by the change in volume. Cool. So what we're going to do is we have our radius in terms of volume equation here. We are going to differentiate it. Now to differentiate it, we're going to take that to the power of 1/3. So we're going to say that dr dv, if we take that to a third and we multiply it down, we're going to have 1/3, big bracket, 3v over 4 pi to the power of, we've got to lower that, we've got to lower 1/3 by a whole, so it's going to be negative 2/3 multiplied by the derivative of the inside function. So that's multiplied by 3 divided by 4 pi. Now for our own benefit, what we're going to do is we're going to simplify that a bit. This third here and the 3 up the top will cancel out. And what we'll be able to do is we'll be able to, because this is a negative power outside the bracket, what we can do is we can use the distributive law to make that a positive power and flip the inside. So what we can have is this is going to be equal to 1 over 4 pi times by 4 pi divided by 3v to the power of 2/3, not negative anymore because we've taken the reciprocal of the inside, and we can now use this formula to calculate what our incremental change in radius is going to be. So what we do is we evaluate, so to find our incremental change in radius, so let me change color again. To find our incremental change in radius, delta r, what we're going to do is we're going to get this function and evaluate it when v equals 500. So we've got 1 over 4 pi times by 4 pi divided by 3 times 500, which is 1500, close bracket to the power of 2/3, multiplied by the change in volume. Now the change in volume is going from 500 to 499, so the change in volume is -1. So if we put all this in our calculator, we get a change in radius equal to 3.3 times 10 to the -3 centimeters, or -3.3 times 10 to the -3 centimeters. So, and you know, that corresponds to a value of 0.0033 centimeters. So basically that's going to be our answer right there. Or you could leave it in scientific notation, it doesn't really matter. But what we've done is we've manipulated this incremental change formula to give us delta R. Now what we had to do as well is we had to manipulate the volume formula, because at the start we had volume in terms of radius. We needed radius in terms of volume, so that's what we did here. And once you've done that, you can literally go, well, the change in radius is going to be equal to the change in radius with respect to the change in volume evaluated at our original point. Volume is this. And then what we do is we multiply that by the small change in radius that we've been given, which is -1. And once we've done that, we'll come out with an approximation for our change in radius. So I hope that helped, and I'll see you again next time.